So let's start with the most familiar group, the Unikonts. I doubt you've heard these labels and things before. That's something you'll have to get used to. The Unikonts fall into two basic groups, the amoebas and the opisthocons. The opisthocons contain a variety of familiar creatures. Fungi, microsporidia, and metazoans, animals. Related to animals are the choanoflagellates. These things, basically a choanoflagellate, if you think of an individual sponge cell, that's what a choanoflagellate is. And it includes some less familiar ones, the chytrids, water molds, nuclearids, etc. And amongst the amoebas, we're talking about a wide range of amoebas, cellular amoebas and acellular amoebas. Acellular amoebas are, obviously they're really cellular, but they're multinucleates. So an individual cell can be quite large and contains a variety of nuclei in it. They are syncytial amoebas. And my favorite syncytial amoeba is Physarum polycephalum. This is not a magnification, this is not a micrograph, this is what it really looks like, and that's a single cell. That's probably magnified a little bit up on the screen. On your computer, it's about life size. These are commonly seen, they can also be orange or pink. They're commonly seen in decaying wood. If you go out to a wood pile, you might be able to find some. Polycephalum comes from the word mini head. This thing is an amazing creature because it can learn. And so if you make a very simple maze where you start it in one place and you have food at the other, food being in fact some colonies on a plate, right? And then you put a dividing line between it. This thing can crawl around very, very slowly, but it can do it. And if you put an electric shock on one path, it will take that path and then get shocked. And then you put it back and start it over, it goes the other way. How this thing can learn, nobody has a clue. It's got no nerves, it's got no nervous system, it's got no brain. Who knows? But it works. If you put it on a plate and feed it a shock, it contracts. And if you wait 5 minutes and give it another shock, it'll contract again. And you repeat this over and over. If you then wait 5 minutes and don't give it a shock, it'll contract anyway, in anticipation of the shock that never arrives. Yeah? It's just an amoeba. Just like an amoeba, these things are kind of analogous to pseudopods, and so it slowly flows over.
So you could put a camera, speed it up.
Yeah, you have to do time lapse and watch it move. Yeah.
That's scary.
The other group are the opisthocons, fungi, animals, and some eukaryotic relatives. By far and away, the most abundant of these creatures in terms of species are the arthropods, and particularly beetles. You'd be amazed at how many species of beetles there are. I just put up the barracuda here just as a fun thing. 2 times 10 to the 6 microns in length, and it's a heterotroph. This particular one, by the way, used to follow us around swimming in Mujin Harbor. He's used to getting hands out. Also, Saccharomyces cerevisiae. Some of you have seen this in lab or something quite similar to it. The familiar budding yeast. This thing, of course, it's a saprophyte. It absorbs nutrients from the environment. It can grow either aerobically or anaerobically. Grown aerobically, of course, it's oxidative phosphorylation. It grows by fermentation otherwise. Interestingly, these things can lose their mitochondria. You can make mutants of them that lack the mitochondria completely. They obviously are anaerobic then, or facultatively anaerobic. They call them petites because the cells are small. Oftentimes, they can grow either as haploid or diploid, and when they're when they're diploid, they're either A or alpha mating types. I have to think a little bit about the life cycle. Well, okay, so when they're diploid, they're A alpha, and when they're haploid, they're either A or alpha. And A and alpha have to come together to create a diploid. Some species of fungi, those two can both exist for extended periods of time, and both the haploid and diploid can divide and multiply. It's also common for the haploids to be essentially gametes, and so they can't divide, but have to fuse with an opposite mating type before they can move on in their life cycle. Oftentimes, those two different phases are morphologically distinct, and so you see a culture with both haploid and diploid mixed together. Sometimes they can be strikingly different, where the diploid is a fungus and the haploid is a yeast. Even Saccharomyces, by the way, can grow in almost filamentous. It forms what are called pseudohyphae, where they form long chains that look a lot like hyphae. And here's the bugs.